Hi, my name is Noe Kristensson, and I'm going to be talking about electronic filters. I'm first going to talk about the math and science of it, and then after that I'm going to talk about some real-life applications and how it can be used. Hopefully that will leave you with a good understanding of how electronic filters are used and how they work.
Okay, so just to give a quick explanation of a electronic filter, then I have made a little graph that shows the frequency of the audio input, and then this red line that goes across the screen. You can look at that as an electronic filter, where it filters out anything that isn't below that line. This is called a band pass filter, and you can see the red lines. That will be the audio output of some file that would go through this filter. So I want to point out that I'm actually using an electronic filter right now to clean out any unnecessary background noise in the audio. So this actually can be quite useful. So just to keep things simple, I'm only going to take one example of an electronic circuit that can be used as an electronic filter. And that circuit is called an RLC circuit. It has four components: a resistance, a coil, and a capacitor, and also a power source. And that's it. So all these three components have in common is something called impedance. And impedance is the ratio between phasor voltage and the phasor current. And the phasor is a complex number that represents the amplitude and phase of a sinoid. Now I think it's well worth it to break that sentence down a little bit. A sinoid is a signal that has the form of the sine or cosine function. And the phase of a sinoid is really just the offset of that sinoid, and the amplitude is just how big it is. So if you go through that sentence again, then you will see it's really just the measurement between the amplitude and the offset of voltage divided by the offset and the amplitude of current. Now the interesting thing about impedance is that it has a different formula for each element. For the resistance of a component, the formula for impedance is really just the resistance is equal to C. Nothing interesting there. But for the capacitor, for example, the formula becomes 1 over 2 times pi times the frequency of the circuit times the capacitor. Now notice this, it's dependent on the frequency. But if you want to find the formula for the impedance of an inductor, well, then the formula becomes 2 times pi times the frequency times L. So if you were to graph the impedance as a function of frequency, then you would see that for the capacitor, the impedance would go down, while the impedance for the inductor, that would rise up linearly. So that would be the inductor, while the resistance, that would just be the same. Now you would notice that there is a point in this graph where the impedance is at its lowest, and that would be somewhere right here. So this point is called the resonant frequency. Now sorry for that pronunciation, I've actually done many takes of this and I've never been able to say it right, so I'm just gonna let it be. But the formula for that is, wait a second, well, that is 1 over 2 times pi times the square root of the inductance times the capacitance. And with this formula you can tweak these values around and get a different resonant frequency. So just to drive that point a little bit further, I've here made a graph that shows the impedance in total of a circuit with the red line, and then also the white lines, those are the impedance of the capacitance and the inductor. And you can see here as I move this around that the red line makes a curve, but the steepness of that curve is changeable. Now That steepness has a name, and it's called the quality factor. Now, I hope that you have a good understanding of how electronic filters work, or at least the RLC circuit. These guys really do have a wide range of usage, all from radio to guitar tuners. But unfortunately, the time is 3 o'clock at night, and I really do have to keep on studying for a test tomorrow, so I'm just gonna have to cut it there. Have a nice day.